These are solutions to exam 4 for Milham's Calc 3 at City College. Number 1, so taking all the midpoints, which are 1/2, 1/2, 3/2, 1/2, 1/2, 3/2, 3/2, 3/2, 1/2, 5/2, and 3/2, 5/2. So double integral is approximately 1, that's dA, f of a 1/2, f of 3/2, 1/2, f of 1/2, 3/2, f of 3/2, 3/2, f of 1/2, 5/2, f of 3/2, 5/2. It's 1 times 1 plus 1.5 plus 3 plus 1.5 plus 1 plus 4.5 plus 3 plus 4.5 plus 1 plus 7.5 plus 3 plus 7.5 comes out to be 39. There was no need to actually do the integration. Number 2, so integral from 0 to pi over 2 of negative cosine y cosine x. Y goes from 0 to pi over 2 dx. So that's the negative of 0 minus 1, which is basically 1. So I'm just integrating cosine sine of x from 0 to pi over 2, 1 minus 0 or 1. Number 3. So integral dy is 3xy plus y squared as y goes from 0 to x squared. Plug in 0, you get 0. Plug in x squared, you get 3x cubed plus x to the 4th. That integral is 3x to the 4th plus x to the 5th over 5 from 0 to 1. Plug in 0, you get 0. So 3/4 plus 1/5, 19 over 20. Number 4, 1, 1, 0, 2, 3, 2. This is y equals negative x plus 2, or x equals 2 minus y. This one, doing the point slope form, slope is a half. Y minus 1 equals 1/2 x minus 1. Solve for x. X is 2y minus 1. Treat it as type 2. That way you just write it as a single function. This is the upper, this is the lower. If you did type 1, you'd have to split it into 2. All right, so integral as y goes from 1 to 2, x goes from 2 minus y, lower, to 2y minus 1, upper, y squared dx dy. Y squared is a constant as far as s is concerned, so the integral is just the length of the interval. So it's y squared times 2y minus 1 minus 2 minus y, length of the interval. This comes out to be 3y minus 3. Okay, so distribute 3y cubed minus 3y squared. Integral 3y to the 4th minus y cubed from 1 to 2. Plug in 2, you get 12 minus 8. Plug in 1, 3/4 minus 1. 4 and 1/4, or 17 over 4. Number 5, theta goes from 0 to 2 pi. R goes from 0 to 2 of x, which is r cosine theta. R dr d theta, which is integral from 0 to 2 pi. Integral from 0 to 2 of r squared cosine theta dr d theta. Integrate with respect to r cubed over 3 from 0 to 2 cosine theta d theta. That comes out to be 8/3. Integral from 0 to 2 pi cosine theta d theta is 0. Okay, you could see this right away if you think of the graph, or get to say sine of theta is the antiderivative. Plug in 2 pi, you get 0. Plug in 0, you get 0. You get 0. Number 6, y equals radical 1 minus x squared from 0 to 1 is the first quadrant part. So theta goes from 0 to pi over 2. R goes from 0 to 1 of e to the r squared, r dr d theta, multiplied by 2 inside and 1/2 outside. So it gives you 1/2. The length of the interval of theta is pi over 2. There's no thetas anywhere here. And so I'm integrating pi over 2 e to the r squared from 0 to 1, pi over 4 e minus 1. Number 7, from the original, 6xz is a constant as far as y is concerned. So I can just put down the length of the interval, which is x plus z. Distribute 6x squared z plus 6xz squared dx dz. Integrate with respect to x, 2x cubed z plus 3x squared y z squared. Plug in 0, you get 0. Plug in z, you get 2z to the 4th plus 3z to the 4th, which is 5z to the 4th. Integral is z to the 5th from 0 to 1. Answer is 1. Okay, how do you quickly come up with the equation of plane? Some of you went through the route of cross product. You can do that, but it's much, much easier to say this. I'm pretty sure I showed you this technique. If you're given 3 points on the X, Y, and Z axes. Just go AX plus BY plus CZ is equal to the least common multiple of 1, 2, and 3, which is 6. So go AX plus BY plus CZ equals 6, and then solve for A, B, and C. So 1, 0, 0, put a 1, 0, 0, that means A is 6. 0, 2, 0, put a 0, 2, 0, that means 2B is 6 or B is 3. And 0, 0, 3, put a 0, 0, and a 3. 3C is 6, C is 2. So the equation is 6x plus 3y plus 2z equals 6. Quick double check. 1, 0, 0 works. 0, 2, 0 works. 0, 0, 3 works. Okay, a little bit of algebra. Z is 6 minus 6x minus 3y over 2, or 3 minus 3x minus 3 halves y. All right, so Z is going from 0 up to the plane, which is 3 minus 3x minus 3 halves y. Now, in the xy plane, I'm looking at going from 0, 2 to 1, 0. Slope of that is -2. The y-intercept is 2. So y equals -2x plus 2, or 2 minus 2x. Double check. When you plug in 0, you get 2. Plug in 1, you get 0. So this is a triple integral. X goes from 0 to 1. Y goes from 0 to 2 minus 2x. Z goes from 0 to 3 minus 3x minus 3 halves y. Okay, number 9. You're integrating r, and then r dz dr d theta. Z goes from -3 to 5. R from 0 to 5, theta from 0 to 2 pi. These are all constants. This does not depend on z or theta, so take them out as lengths of the interval. The length of the z interval is 8. I put a z there. The length of the theta interval is 2 pi. I put that there. So I'm just integrating r squared dr. So it's 16 pi r cubed over 3. Plug in 0, you get 0. Plug in 5, you get 125. 2,000 pi over 3. And finally, 10. So x squared plus y squared plus z squared is rho squared. Then rho squared sine phi, d rho, d theta, d phi. Rho goes from 0 to 2, theta from 0 to 2 pi, phi from 0 to pi. Watch out, it doesn't go from 0 to 2 pi. We said you get the whole thing from 0 to 2 pi. And if you made the mistake of putting in 2 pi, you would end up with 0, which some of you did. Okay, this does not depend on theta, so take out the length of the theta interval, 2 pi. Okay, I got rho to the 4th, sine phi, d rho, d phi. So that's rho to the 5th over 5. Rho goes from 0 to 2. Plug in 0, you get 0. Plug in 2, you get 32 over 5. Multiply that out, 64. Pi over 5, integral of sine phi. Negative cosine phi from 0 to pi. Negative 64 over 5. Cosine of pi is -1. Cosine of 0 is 1. So combine that with that, 128 pi over 5. Okay, so I'll do the focusing thing again in case you couldn't see what I did, but these are the solutions for exam 4 for Melham's Calc 3 at City College. Get you all of this. There's all that. Seven. All right, so that'll do it for this test.